Have you ever stopped to wonder about the invisible forces that are just running everything? From flicking on a light switch to all the sounds that fill our day, there's this kind of hidden code at play. Well, today, we're going to unravel that code and really dig into the science behind our everyday world.
It's a question we don't really stop to ask much, is it? I mean, think about it. Your TV, your fridge, even your printer, they're just part of life. We totally take them for granted. But the truth is, every single one of them is a little marvel of science. And understanding how they work, that's the first step to seeing the world in a completely new way.
So let's go on a little journey to demystify the everyday stuff. We're going to explore the fundamental principles that control everything from the light we see to the sounds we hear. And our first stop is going to be the very thing that makes vision possible, light itself.
Right, so light. It's the first thing you see when you wake up and the last thing you see before you fall asleep. It's so basic to our existence that we forget to ask this simple question. What even is it? Well, the answer is both super simple and kind of profound. Light is just pure energy.
Okay, imagine ripples in a pond. Got it? Now, instead of water, we're talking about waves of pure energy. That's basically what light is. It's this incredible dance of electric and magnetic fields vibrating through space. And it doesn't matter if it's the warm glow from the sun or the cool light from your phone, it's all the same amazing phenomenon. And this is where it gets really wild. The entire rainbow of colors that we can actually see is just a tiny, tiny sliver of the full spectrum of light. We're literally surrounded by invisible waves all the time, from the UV rays that can give you a sunburn to the infrared waves that we feel as heat. Our eyes can only pick up this one little fraction of a huge invisible world.
Think of your eyes like a camera and your brain like a supercomputer. When light waves hit your eye, they get turned into an electrical signal. That signal zips to your brain, and in a split second, your brain processes all that information and creates the rich, detailed world you see around you. It's a biological miracle that's happening every single moment you're awake.
Okay, so just like light waves let us see, another kind of wave lets us hear everything around us. So now, let's tune in to the physics of sound and find out how simple vibrations create the entire soundtrack of our lives.
You ever feel the bass from a big speaker vibrating right through your chest? Yeah, that's the power of sound waves in action. Every single sound you hear, from the quietest whisper to a huge clap of thunder, is just something vibrating. It sends these ripples of energy through the air and eventually into your ears. And it's simple. The bigger the vibration, the louder the sound.
This is a great way to see how volume actually works. A really gentle hum creates a small, kind of delicate wave. But a loud shout, that creates a huge, powerful wave. The height of that wave, what scientists call its amplitude, is basically a direct measurement of how intense the sound is. It's like the difference between a gentle breeze and a hurricane, but for sound. Now, let's talk about pitch. The difference between a deep, rumbling bass note and a high, piercing whistle. That's all about how fast the sound waves are vibrating. A low pitch has these slow, lazy waves, while a high pitch has really fast, almost frantic waves. It's this beautiful interplay between volume and pitch that creates all the amazing sounds we hear every day.
All right, so we've gone from the invisible waves of light and sound to the physical world of stuff that actually moves. Our journey now takes us to the universal rules that govern motion itself. These are the laws that Isaac Newton figured out, and they apply to literally everything, from an apple falling off a tree to a rocket blasting into space.
Ever notice how a soccer ball will just sit on the grass until someone comes along and kicks it? Or how a rolling ball just keeps on rolling until it hits a wall or something? That's this law, the law of inertia in a nutshell. Basically, objects are kind of lazy. They'll just keep doing whatever they're doing until some force comes along and messes up their plans.
This is such a perfect way to picture it. That nail has zero intention of moving. It's just sitting there. But then the hammer comes along and provides the force it needs to move. It's a super simple but really powerful way to see how forces change what objects are doing.
So Newton's second law takes this idea a little bit further. See, it's not just about getting things to move, it's about how quickly they move. The heavier something is, the more mass it has, the more force you need to get it to speed up. That's why you can send a soccer ball flying with just a little kick, but you'd need a way bigger push to get a bowling ball rolling at that same speed.
And now for a law you've almost definitely heard before. For every action, there is an equal and opposite reaction. This is the bedrock principle of balance that governs every single interaction in the universe. When you push against a wall, guess what? The wall is pushing back against you with the exact same amount of force. It's like a cosmic game of tug-of-war that's happening all around us all the time.
The swing set is just the best example of this law in action.
Your push, that's the action. The swing moving forward and away from you, that's the reaction. The force you put into the push is perfectly balanced by the force of the swing moving away. It's a really beautiful demonstration of the delicate balance of forces that makes our world work.
So we've looked at light, we've looked at sound, and we've looked at motion, but there's one single thread that ties all of them together: energy. You can think of energy as the currency of the universe. It's the driving force behind everything we've talked about. It's the master key that unlocks all the secrets of our reality.
Now, this is one of the most important and, frankly, unshakable laws in all of science. Energy cannot be created and it cannot be destroyed. It can only change from one form to another. The energy that powers our sun, the energy in the food we eat, the energy lighting up our cities, it's all part of a closed system, a cosmic dance of transformation that's been going on for billions of years.
To make it simple, think of a roller coaster sitting right at the top of a giant hill. All that height, that's potential energy. It's stored up, just waiting to be unleashed. And then, when the roller coaster plunges down the track, all that potential energy gets converted into kinetic energy, the energy of motion. Our entire world is this constant back and forth between these two states, just a non-stop cycle of storing and releasing energy.
This archer is just a beautiful illustration of that energy switch. The act of pulling back the bowstring stores a ton of potential energy in the bow itself. And the second the string is released, that potential energy is instantly converted into the kinetic energy of the arrow flying through the air. It's a perfect example of energy changing its form, but never, ever disappearing.
So there you have it. From the light we see to the sounds we hear, from the motion of planets to the energy that powers our lives, we've kind of uncovered the hidden code that runs our world. These aren't just dry scientific principles, they are the fundamental rules of our reality. They're the invisible architecture that shapes every single one of our experiences.
The world around you really is a symphony of science, a beautiful and intricate dance of light, sound, motion, and energy. So now that you know some of the steps, what new wonders will you discover? The universe is just waiting for you to explore its secrets. Thanks for joining me on this little journey of discovery.